Hello everybody, my name is Sameer Pava and today we will be doing HOTS questions on number system for class 9. So our first question says, I'll draw a line here. Our first question says 10 divided by 5 root 3 minus 3 root 5. So the objective of this question is to rationalize the denominator. If you have read the number system chapter, you may be familiar with the term rationalizing the denominator. So I'll start by rationalizing it. There are two methods of rationalizing. The first one is the long cut method and the second one is the shortcut method. I'll teach you first the long cut method. So I'll multiply this with 5 root 3 plus 3 root 5 into 5 root 3 plus 3 root 5. Don't be confused at why am I multiplying this with a plus. I'll send the link of my video on rationalization. You can see that and you'll get the reason. But for now, I'm writing a plus here because it always needs to be the opposite operation. Suppose if there was a plus here, then I wouldn't have written plus here, I would have written a minus here. Don't ask me why, it's a rule. And it has even been stated in the NCERT course books. Yes. So now 5 into 10 plus 3 into 10. That will give us 50 root 3 plus 30 root 5. Now this is our final numerator. No need to touch this. Keep it aside. Now the denominator is a bit complex. It's a lengthy one, but if I teach you with the shortcut method, you'll find it very easy. So I'll start by doing 5 root 3 minus 3 root 5 into 5 root 3 plus 3 root 5. It can also be written as 5 root 3 into 5 root 3 plus 3 root 5 and minus 3 root 5 into 5 root 3 plus 3 root 5. So this is the long cut method. 5 root 3 into 5 root 3 can be written as 5 root 3 square. This has to be simplified, so I'll keep it for later on, okay? And plus 5 root 3 into 3 root 5 can be written as 5 into 3 15 and root 3 into root 5 15 root 15. And then excuse me, minus 3 root 5 into 5 root 3. It can be written as minus 5 root 15 and minus 3 root 5 into plus 3 root 5 can be written as, we can't write a minus 3 root 5 square, so we'll leave it aside for simplification. Fine. So now to simplify the denominator, these both will be cut off as they have the same values. Yes. So 5 root 3 square can be written as 5 square into root 3 square. Don't be confused by this sign. This is the sign of multiplication. This is the sign of multiplication. So this comes out to be, the end result comes out to be 25 into 3. So what is 25 into 3? 25 into 3 is 75. Okay. Now minus 3 root 5 into plus 3 root 5. 1 second, I'll highlight the answer. Yes. Minus 3 root 5 into plus 3 root 5. Minus 3 root 5 into 3 root 5 can be written as minus 3 into 3 into root 5 into root 5 I'll write a cross sign for clarification. Minus 9 into 5 gives us sorry for that, minus 9 into 5 gives us minus 45. So our denominator finally comes out to be 75 minus 45, that gives us 30. This is our denominator. Now our final simplified version comes out to be 50 root 3 plus 30 root 5 divided by 30. Now if you want to simplify it, what you can do, that you can cancel out the zeros. It will be much more comfortable and much more simple, will be a simplified version. That will give us 5 root 3 plus 3 root 5 divided by 3. This can also be written as 5 root 3 divided by 3 plus root 5, because these both parts will be cut off. So this comes out to be our final answer. Now you can take a screenshot of this solution if you want, because I'm now going to erase it. I hope you have understood it. If you have any doubts, you can post them in the comment section and I will surely answer those doubts. Fine. I'm not erasing it completely. It will take quite a lot of time to do so. That's why let's proceed to the next question. The next question says, root 5 minus 2 divided by root 5 plus 2 minus root 5 plus 2 divided by root 5 minus 2. Now you may be thinking that I'll have to take out the LCM of both of them, right? No. If you thought this, you are wrong. An LCM can be took out, but it will be way too complex to do so. That's why I have a much simpler method. This is based on our earlier used concepts only. So what I aim to do is, I'll write it in steps. Let's take this as part A and let's take this as part B. So first step will be to rationalize part A, part A, and number 2, rationalize part B. And then my third step will be to subtract both of them. Subtract, right? These are my 3 steps. Now according to these steps, let's move on with our sum. So I'll take part A, which is equal to root 5 minus 2 divided by root 5 plus 2. So I'll rationalize part A as said. So I'll rationalize it into root 5 minus 2 into root 5 minus 2. Okay. So root 5 minus 2 into root 5 plus 2 will give us 5 minus 2. Now you may be confused in this step if you're not familiar with the polynomials chapter. So I am very sorry for that. So I'll even explain it with a long cut method. So I'll first of all tell the algebraic identity we are using for this. If you are not familiar with the chapter or you haven't read it, that's not a problem. I'll make a separate video on this kind of algebraic identity. So for now I'll do it with the long cut method also. Root 5 plus 2 and minus 2 root 5 plus 2. Okay. Root 5 into root 5, 5, and 2 root 5 minus 2 root 5 minus 4, this gives us 1, right? I'm sorry for this mistake. I meant to write 4 here. I'm really sorry. So the denominator comes out to be 1 in the end. Now the denominator was very easy in this part. It's the opposite of the last time sum. In this sum, the numerator is hard. Now the numerator is also based on an algebraic identity. It can't be solved like the denominator as we did earlier. In the denominator, you may have noticed that there's a plus sign here and there's a minus sign here. But here we have a minus sign and a minus sign. So we can't apply the same method. That's why we'll use the algebraic identity a minus b whole square is equal to a square plus b square minus 2ab. I'll make a separate video on that. For now, please cooperate with me and please use this algebraic identity to solve the sum, because there is no as such other way. So I'll get, according to the identity, root 5 square plus 2 square minus, that was some technical glitch, I'm sorry, minus 2, and root 5. That gives us 5 plus 4 minus 4 root 5. That gives us 9 root 5. Sorry, 9 minus 4 root 5. 9 minus 4 root 5. This comes out to be our final answer. But remember, our answer isn't done yet. This is only for part A, right? So now moving on to the part B. I'm sorry, I used the wrong pen. Part B says root 5 plus 2 divided by root 5 minus 2. So I'll do the same steps. Root 5 plus 2 into root 5 plus 2 is equal to this. For this we'll use an algebraic identity called, one second, a plus b whole square. That gives us a square plus b square plus a square plus b square plus b square plus 2ab, right? And again we'll follow the same steps. 5 minus 4 will give us 1. Yes, it will give us 1. So I'll quickly end this sum. I'll get a square. Our a square will be 5, b square will be 4, and 2a will be 2ab will be 4 root 5. Now our final answer will be 9 plus 4 root 5. Now comes the trickier part. It's not tricky at all, but many students forget it and they lose all of their marks. The subtraction part. Fine. So our part A is 9 minus 4 root 5. Okay. And our part B is 9 plus 4 root 5. Pause the video and tell me your answer in the comments. What do you think is it? Now most probably I know what did you think. Your answer will be 9 minus 9 and minus 4 root 5 plus 4 root 5, which will be 0. But that's not the case. Remember, this is one blunder any student can commit, and it's a very silly mistake. Okay, so now what the trick is here, that we have to put a bracket here. That will give us 9 minus 4 root 5 minus 9 minus 4 root 5. So 9 minus 9 0, and our final answer is minus 8 root 5. Our final answer. I hope you liked this session, and if you have any feedback for me, you can write it in the comment box. You can even post your doubts, and you can send me sums to solve, which I will solve in my next video. So I'll tell you the topic of the next video. The topic of the next video is to solve the third question. I didn't solve the third question this time because it's an exponent's HOTS, not an operations HOT. Thank you for watching my videos. I hope you like them. Please like, share and subscribe. Thank you.